Okay, so the hierarchical design and redundancy of the internet has enabled it to grow into a worldwide innovation that changes in a hierarchical way. So, within the design of the internet is a lot of redundancy. When data is sent from one part of the network into another, the data is broken into blocks of bits called packets that contain enough information so each packet can be rerouted if necessary. The way data moves through the system is controlled by several protocols that manage communication and security between hardware and software. The way data is broken and reassembled is called TCP/IP, Transmission Control Protocol and Internet Protocol. This is important. Routing between 2 points on the internet is redundant since there is more than one way for the data to move from point A to point B. If a packet doesn't arrive, it may be rerouted. The data is secured through something called the secure socket layer or the transport layer security protocols. And the data is processed and viewable only through hypertext transfer protocol. Now, when we're measuring how much data is traveling across the internet, it's measured in something called bandwidth. So the size of the information being sent at any time is measured in bits. How much time it takes a request being sent and when it is received is called latency. And then we say bandwidth is a calculation. You take the number of bits divided by the time, the latency, the time it takes the request to be sent. To see bandwidth on your current connection, use a tool called speedtest.net. Okay, now, security on the internet, we often call cybersecurity, is important. It's a big, important concern for internet and all systems. It's a balancing act between our need to communicate what we want to share and our need to protect our personal information. Most people are using the internet, more people that are using the internet than ever before, making security a huge issue. Communication often falls into two following categories. So when we're communicating on the internet, we're either doing it socially, for a business or school related reason, to financial transaction, making a purchase or doing banking, or device centric. A device like your phone is accessing online data or software to run other applications. As people continue to enjoy using the internet, they also want to control how much information is being communicated. This occurs in many ways. Additional use of the internet means new vulnerability to data, protocols to ensure security when you access or when you share personal information on the internet. And there's a lot of questions related to data vulnerabilities created while using a browser. So, what happens when you use a browser? So, you open the browser to go to a website. Your computer verifies that you have an internet service provider like Comcast. To have an internet service provider, um, they can access your IP address. This IP address can be used to find geographic location you are using to access the internet. So if the internet service provider has your IP address, they basically know where you are. Number two, you enter the name of the site as words into a browser. The domain name server translates your words into an IP address. Your request is recorded by your browser. Protocols used by your computer's browser will allow you to take advantage of the fact that you have connected to the internet. File retriever and file transfer protocols are a collection of protocols that allow you to view and or download online information. There's a term called caching that is used to make this process more efficient. If you have been to a website or a location before, it'll be stored in your cache so it downloads faster. Browser keeps digital records of searches that you have performed using something called the search history. Your browser also creates small files called cookies when you interact with a website. These are used by other sites to identify you by your preferences and to create targeted advertising. You may need to type a password access um, to access what you need at a location. Websites have software that records your password to check that it's you Your browser may offer you to save the password so you don't have to remember it. Now your password isn't in two places, and we shouldn't do that. That's risky. You view a site and access information you need. File retrieval and file transfer are allowing you to interact with the site, and new pages are added to your cache. Cookies continue to be created depending on what you interact with while you're on the site. Increasingly, people are giving permission to devices to access the internet. As more and more devices are connected, this way of using the internet is called the Internet of Things. This will only make security more essential. Beyond browsing, consider these examples when you're using the internet. An application running on your phone, like social media. A source for saving media on your computer, like Google Drive. An application that allows you to video chat, like FaceTime. The place your phone accesses to learn which update is needed. Software for GPS. Digital requests like Siri are translated to a request to a browser or other software. Innovations that rely on the internet, as they increase, so do our needs to access information. And as society begins to rely on the Internet of Things, meaning almost everything we're using is connected to the internet in some way, we need protocols for each of those things to be open and secure. To allow as many people access to information and protect this information, the internet is open. Important parts of the open nature of the internet include the domain name system. The domain name system is transparent. Communication protocols are public. When a device is given an IP address, that device must communicate using accepted protocols. Protocols are open, so people designing devices know how to follow the set of rules that are governed by the IETF, the Internet Engineering Task Force. These protocols are necessary to keep information secure, and these protocols evolve as the internet changes. So cybersecurity relies on open standards. It consists of cryptography and protocols. Cryptography is the use of math algorithms to encrypt and decrypt information. Each encryption and decryption involves the use of a key, a number that is used to hide or expose information. Certificate authorities, CA, issue digital certificates to validate that the key being used in encryption is owned by the user. There are two types of encryption, symmetric encryption and public key encryption. Symmetric encryption uses a single key to encode and decode, but public key encryption uses two keys, one public and one private, to encode and decode, and this is called asymmetric encryption. Think of a private key as a one-way lock. An example is a library drop-off. You can put books inside, but you cannot remove them. The last thing I want to talk about is the SSL TSL, the secure layer, secure socket layer, transport layer security. They are cryptographic protocols that use both types of encryption. These protocols are used by many devices to provide security during communications over the internet. The steps involved include establishing a connection. One device attempts to connect to another. There is a handshake protocol where each party proves they are who they say they are using a public and private key. This step takes the longest. A certificate authority issues a digital certificate to verify that the encrypted key is owned by the site being contacted. After the handshake protocol is successful, communication is encrypted with one key, symmetric encryption. The handshake protocol is not successful, the entire SSL TLS protocol must be reattempted. Public key encryption is used during the handshake protocol of SSL TLS. Symmetric encryption is used for the remainder of the time when the two parties are exchanging information.